Okay, guys, as the topic polynomials is being continued from the last video, and in my last video, I have discussed about factor theorem and remainder theorem, and I solved exercise 2.4 also in that video. But the question number 5th of the exercise 2.4, I left it. That is unsolved in my video only because some of algebraic identities, which is the topic of our discussion today, is used in that question. So don't get confused. I will solve this question, that is question number 5 of exercise 2.4 with the exercise 2.5. So that in continuing this, today the topic of our discussion is algebraic identities, means how to use some algebraic identities to factorize the polynomial. As in this chapter, when we introduce polynomials and doing continue it, we have reached to the point where we have to find factors of algebraic expressions. So how to factorize the algebraic expressions or the given polynomial, that is the question. As we discussed it in factor theorem, some of the questions, some of the expressions, algebraic expressions can be factorized with the help of factor theorem, but that method is very long, and by hit and try we find that factors, but that was a long method. So matter is not of short or long, matter is how to factorize in a easy way in which we have to consume or we have to use less time, and the process must be effective in all type of algebraic expressions. So in that way, some of identities I will discuss here. The first one is very simple, that is x plus a, x plus b. If we multiply it, we will get x square a plus b into x, a into b. Now why this identity is used, means it is just a multiplication of two factors. So why it gives the name? Because we can use this form to factorize the polynomial in a way, and I will discuss this process. How? This is its left side and this is its right side. So if we have to go to right side from the left side, means if the factors are given and we have to find a polynomial, then we multiply these factors, we will get polynomial. But if a polynomial is given and we have to factorize it, then we have to follow the reverse process of multiplication. So the process, that is reverse process of these identities is used. How to use? Now if this polynomial is given, okay, then first you have to think or you have to look that what is multiplication, what is coefficient of x square, means what is coefficient of this term, okay, that must be 1. Second, the coefficient of x, single power, okay, this is here write a plus b, means two values are add here, right? And the third term, which is constant term, is multiplication of this AB, right? So you can remember it in the form x square minus sx plus p, right? What is s? S is sum of two values, and what is p? Product of that values. Okay, so a and b are fixed. This is sum and this is product. So if we want to find the factor of this polynomial, then what we have to do? We have to find the coefficient of x. Okay, and that coefficient must be broken in two values, right? Such that values must be conditional. What is the condition? That values must have some, that coefficient, and product of that values must be the constant term. Okay, you can take example, very easy example, like that. If you have x square plus 3x plus 2, this is the polynomial. Now we have to find the factor of this, right? Means reverse process of this identity, means we have to go left from the right? Okay, now the first point is 1, that coefficient of x square must be 1. Here is 1, right? Now the coefficient of x, what is here? That is 3. Right here 3. You can give the name s, that is 3. Okay, this is sum, and the coefficient term, that is product, that is p, which is equal to 2, right? Now we have to break this number, this coefficient, that is 3. How can you break this? And what type of number you have to choose? Natural number, whole number, integer, rational, irrational. What would be the number? Number must be any. Any means real number. So that is not a condition that you have to choose just only integers or only natural numbers. You can choose any real number, right? Now, as you have to break this 3 into 2, 1, what would be that? We have to find two numbers, and you can try from simple mean integers. 3. What is the two integers which some have 3? 1 and 2, 2 and 1. Okay, this is 2 and 1, right? 2 plus 1, that is equal to 3. Can you write it 1 plus 2? Yes, 1 plus 2 is also equal to 3. Now these number must have multiplication equal to this. You can check. Okay, that is 2 into 1, which is equal to 2. So this 3 is broken into two numbers which has multiplication equal to this p, that is product, right? Now these two numbers are 2 and 1. So write here as 2 plus 1. This 3 can be written as 2 plus 1. And this is 2. Now you can multiply this x to both these numbers, right? And you have to take common as x. Here you will get 2, and from this nothing is common, so write here as it is, but in multiplication you can write 1, because if this number is multiplied by 1, nothing would be changed. Okay, now this x plus 2 is common, and in remaining you will get this factorial x plus 1, right? So this is the process, right? I again repeat, here the coefficient must be 1 according to this identity, right? Then the coefficient of x, take this value and break it into two values. What is the condition? That two value must have product equal to this value, right? So you can factorize. This is the way, right? But you can keep in your mind that when you break these in two values, then you have to write first larger one and then smaller one. Okay, this is not a process, not a point, not a formula, but just to make a sense that it will be easy and you can find this easy one to take common these factors, right? So this identity can be used in the questions where the algebraic expression or a polynomial is given and we have to factorize that polynomial, right? This is the first identity. Now the second one, x plus y equal to square of first 2 into first into second and square of second, right? Again, be okay. This is left side, this is right side. If you have given left side, we have to find right side, and if we have given right side, we have to find left side. So if a polynomial is given or a square polynomial is given, we have to make factors like this we can find. Okay, so when we will do questions, I will explain it, and very easy one, because in your earlier classes you have learned about it. I will make application, I will try to explain its application in the questions, so don't get confused. This is plus and this is minus, so be okay if you write here plus, then the first one is x, the second one is y, and you can remember it as square of first 2 plus 2 into first multiply second plus square of second, right? This is also here square of first 2 into multiply of first and second, and this is square of second, right? So if you have plus sign, then all are plus, and if you have minus sign, then you can take minus sign as here, and if you will multiply this plus with minus, you will get here minus sign. Okay, and this minus sign will be waived off because of square term, because square term means two term multiplies, minus multiply minus is always equal to plus, so it is waived one. Now the fourth identity, which is also very important, you can write here as square of first, right? I will write here as first square and second, this is also square, right? You will get first minus second and first plus second, right? So you can remember as first minus second, first plus second, and you will get these two factors, x minus y, x plus y. Okay, this is fourth one, and all these are, you can give a name square identity because all are limited to the square power, means quadratic one. Now these are only two terms. Okay, so this is, now fifth one is containing three terms, x plus y plus z. So square of first, square of second, square of third. To multiply first into second, second into third, and to multiply third into first, right? So you can remember these, and the next one would be cubic identities. And also if you have two terms, then x plus y cube you can take here as cube of first, cube of second, and 3 first into second, or plus first plus second. Okay, again you can take minus term here, x minus y, as x cube minus y cube, 3 into first and first minus second, right? And next one would be x minus y minus z. So you can take cubic of third terms, that would be much bigger one, and I think that would be beyond the scope of this book, but identity of this type may be used here, that is x cube plus y cube plus z cube minus 3 xyz equal to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. Okay, so we have to keep in our mind that if we find the reverse process of these identities, then we have to remember the forms of these identities. Okay, so if a question is given of this type, then you have to identify that question which is equivalent to which of these identities. And so I will try to explain that in the exercise, in the question, in the solution of the question of this exercise. Okay, so now we can start the exercise, that is 2.5. Exercise 2.5. The first question, first part. Okay, use suitable identity, means using these identities discussed above, find the product of this one, x plus 4, x plus 10. Okay, what is the identity? Means what is the form? Means this question which belongs to these identities, that is first one. Then you have to write here as using identity x plus a, x plus b equal to x square a plus b into x ab. Okay, so compare it with the given terms, given factors. That is, here if we compare, you can write here as comparing, we get a equal to 4, b equal to 10, right? A equal to 4, b equal to 10. Now using these identities, we have to write here x square, okay, plus a plus b. What is value of a? That is 4. What is value of b? That is 10. So a plus b mean 4 plus 10. Multiply x plus a into b means multiply of 4 and 10. That is 4 into 10. And you will get this x square, that is 14x, and 4 into 10, that is 40. So this is the question. We have to multiply these two factors using identity. Okay. Now you can take another example, another part, that is 3x plus 4 into 3x minus 5. So using again that identity, what is identity? X plus a, x plus b equal to x square, a plus b into x, a into b. Okay. So here if we compare, the multiplier of x is 1 and here it is 3. So first we have to make these factors of this form, right? How? You can take common 3 from here. You will get x plus 4 by 3, and 3 also from here. You will get x minus 5 by 3. Okay. Now this is 3 into 3. You will get 9, x plus 4 by 3 and x minus 5 by 3, right? Now comparing x plus 4 by 3 and x minus 5 by 3 with x plus a, x plus b. Okay, we are following the process, right? So here coefficient of x is 1 and also 1, so you see, then a equal to, what would be a? 4 by 3, and what would be b? Minus 5 by 3, right? Minus 5 by 3. Now using this, you can write, that is x square plus a plus b. What is a? 4 by 3. What is b? Minus 5 by 3. That is a plus b, right? And multiply of ab, that is 4 by 3 into minus 5 by 3. Now calculate this and you will get 4 by 3 minus 5 by 3 minus 1 by 3, multiply x, right? And here that is 20 by 9, right? And you will get x square minus 1 by 3x minus 20 by 9. This is multiply of these two factors, but as you know, we have to find this. Now write it as 3x plus 4, 3x minus 5 equal to, put the value in this term. This is 9, right? This is 9. Okay, this is 9, and multiply of these two factors is equal to this. So x square minus 1 by 3x minus 20 by 9. Now multiply it with this, that is 9x square, and if you multiply it, it will cancel 3 and you will get this. This is the required multiplication. So if the coefficient of x and y is not 1, then you have to make first 1 by taking common that factor, right? And then apply the identity and find the multiplication of that factors, right? So I think you can do without much problem. I am taking fourth part of this question also, that is y square 3 by 2 and y square minus 3 by 2, right? Now you have to make first applicable to the identities. So what will you do? Here we see that here is quadratic term, but in our identity here is linear term. So you can put or taking y square equal to x. Okay, you will get x plus 3 by 2 x minus 3 by 2, right? Now it is linear one. So which identity you will use? The above identity. In above questions we have used that identity. Here also you can use. Also we see that the form of this expression is belongs to identities. The first one is x plus a into x plus b, and the second one is x plus a into x minus a, right? So both these can be used, which you will use using x minus a, x plus a, right? That was x square minus a square, right? So comparing, you will get a equal to 3 by 2, and so x plus 3 by 2 x minus 3 by 2, it will be x square minus 9 by 4, right? And putting value of x, that is y square, you will get the required answer, y square square, that is y4 minus 9 by 4. Okay, so you see the application of these identities. Now come to the question number 2, part 1. Evaluate the following product without multiplying directly. 103 multiply 107. So we have to find the multiplication of these two numbers without multiplying directly. Means you have to use identities. So first make the form of identity, right? Here we see that is 103 and that is 107. So we can write here as easy number. Easy number is 100. 100 plus 3, 100 plus 7, right? So this form belongs, or you can say this type of form, and this identity may be used. Okay, by comparing we will get value of a, that is 3, and value of b, that is 7, and value of x, that is 100. This is the point to be keep in mind. What is the point? Point is that in this identity this is the same, so we have to make factor of these two numbers which have the same value. If it is different, then this identity will not work, right? So multiplication may be written as square of x, that is 100, a plus b, that is 3 plus 7, into x, that is 100. Multiplication of a and b, that is 3 into 7. What is value of this number? You will get 4 zeros, that is 10,000. This is 10 into 100, this is 21. This is 10,000, this is 1,000, this is 21. This is 11,000, this is 21. You will get. Okay, very easy, and I think the point is clear. Now I can take here third part of this, that is 104 multiply 96, and you see you can break this 104 into 100 plus 4 and 96 100 minus 4. Okay, that is x plus a, x minus a, and result of this identity was x square minus a square, and you will calculate. I will left it for you. Okay, easy one. Now come to the question number 3. Factorize the following using appropriate identities. The given expression is 9x square 6xy plus y square. Okay, which identity must be used here? As I have discussed, as we have identity x plus y square equal to square of first 2 into multiply xy and square of y, that is square of second, right? So this form is given here, right? So we have to make the factor of this expression, this polynomial, into this form. How? We have to follow the reverse process. How? We have to make this form of this, right? How? You read here as first square 2 into first into second, or plus square of second, right? So this is the first one. Now make this term first as here this is first. Okay, write is it as this is first, the whole term, right? The second one is 2 into first, 2 into first. What is first? That is 3x. Now what we have get here? 6x. 6x complete. remaining part is just y. Write here as y, right? And the next one is square of second. This is first and this remaining is second. Okay. Now close this identity as first plus second. This is first 3x plus second, that is y, and this is whole square. So you can write here also. Okay, so the reverse process you have to keep in mind how it is done. I am taking third part also of this question, x square minus y square by 100, and we say the form of identity here is used, x square minus y square. What is that? X minus y, x plus y. And keep in mind, this is first, this is second, first minus second, first plus second, right? So this is first and this is second, and you will get first minus second and first plus second. I think you have clearly understand the process of factorization of the polynomial using identities. Anyway, if you have any doubt, you can put that doubt in your comment box. Also, please subscribe our channel and click on bell icon to get latest video of our channel, and please inspire us clicking on like icon. If you have any doubt or query, you can feel free to share it in the comment box. And the motto of putting these videos is only to clear all doubts. The doubt must be cleared, no doubt remain. Okay, now come to the question number 4. Expand each of the following using suitable identities. I will taking third part of this question, that is 2x plus 3y 2z and whole square, right? Now, so the identity use here using x plus y plus z square, x square y square z square, 2xy 2yz 2zx. Okay, so you can rename these terms as first, second and third. The first one is square of first. What is first? That is minus 2x. Square of this. Square of second. Second term is 3y. Means square of 3y. Third, square of third. Third means 2z. Square of third term. Then 2 into first into second. What is first? First is 2x. What is second? Second is 3y. 2 into second and third. What is second? 3y and third 2z. And 2 into first and third. First is 2x and third is 2z. Okay. Now you will get this 4x square, minus is waived here, 9y square, 4z square. Okay, minus plus minus, 2 into 2 into 3 12, xy 2 3 6 into 2 12yz plus minus minus 2 into 2 into 2 8xz. So you see very easy one question, and I think there is no any technical point in these questions, and you can easily apply identities. Just you have to keep which identity is used, and also you have seen that reverse process of identity is more important than the direct process, right? Now come to the question number 5. Factorize this, and the given expression is 4x square 9y square 16z square 12xy 24yz 16xz. So the identity as above, we have given that x square plus y square plus z square plus 2xy 2yz 2zx that equal to x plus y plus z whole square. Means we will use this. Now this is square of first term and this is the first term, that is 4x square. So we can write it as square of 2x. This is square of second term. What is second term? That is 9y square, and we can write it as 3y whole square. Third, 16z square. We can write here as 4z whole square. Plus 2 into first into second. This is first, this is second. What is first? 2x. What is second? 3y. Now verify this value. 2 into 2, 4. 4 into 3, 12. 12xy. And we have also here 12xy. Right? Plus 2 into second into third. What is second? Second is 3y. And third is 4z. Again verify. 2 3 the 6 into 4 24 yz. Here 24 yz. But be careful. Here is symbol negative and we have positive. So how will you use or adjust this negative in these numbers? As we have seen that in this term the first and second both term are positive, nothing is negative, right? And second term is 3y, means 3y is positive, so we cannot write here negative sign. The remaining term is third, that is 4z, so this 4z may be negative. I use the word may. How will you confirm this? Next term will confirm this. What is next term? That is 2 into third into first. What is third? That is 4z. And what is first? That is 2x. Now the number is, in verifying, 2 4z 8 2z 16, that is 16, and xz, this is xz, but here also this is negative sign, so one of these factor must be negative. What would be that? 4z or 2x. Now if you use 2x as negative, then this 2x must be negative and you will get this negative number, but we have this positive number. So first is not negative, and in the second term we have proved that second is not negative, so the third, remaining third is negative, and this confirms that 4z is negative. So both these terms will verify each other what factor must be negative. So keep this 4z as negative. Here negative sign does not have any meaning, right? But when you close this identity, you will use this sign, right? So 2x which is positive, 3y which is positive, 4z which is negative. So this is negative, this is positive, and this is whole square, right? I think you have clearly understand the process, the reverse process of this identity, right? So keep the sign in mind and choose the right factor of sign, positive or negative one. Okay, I will take also second part, that is 2x square plus y square 8z square 2 root 2 xy plus 4 root 2 yz minus 8xz. The above identity again will be used here. Okay, how? This is first term. So this first term, square of first term, how will you write here? It is 2. So root 2 you can write, because when you find the square of this term you will get 2x square, right? This is nothing but y. Again z, but how will you write 8? 2 root 2. 2 root 2, square of 2 root 2, that equal to 8, right? Again that is 2, right? Sorry, plus 2. First into second, first is root 2x and second is y. Now verify this. This is 2 root 2 xy. This is 2 root 2 xy. Number is verified, but here is negative sign and here positive one. So one of the factor is negative. Which one? We don't have. Okay. Now come to the second term. That will verify which one would be negative, right? 2 into second into third. Second is y. Third is 2 root 2 z. Now verify this term. 2 into 2, 4. 4 root 2 yz. We have 4 root 2 yz. And this is positive. This is positive. Means y is positive. And root 2z is also positive. Okay. So here it is clear that y is positive. So the remaining term, this may be negative. Till now it is not confirmed it is negative or not, but it's showing sign. So come to the third one, that is last. 2 into first into second, third, 2 root 2 z, right? Again 2 to the 4, 4 to the 8, 8xz. This is 8xz, but this is negative. We have positive. So one of these factor is negative. What is negative? In the first term we find that root 2x may be negative. So if we write here it is negative, but in the second term it is clear that 2 root 2 z is positive. So it is positive. So remaining this point is negative. So keep this term negative, right? Now this is root 2x, this is y, this is 2 root 2 z. This positive, y positive, this negative, and this is all square. Okay, I think there would not be a big problem on. And now come to the question number 6. I will take fourth part of this one. That is, we have to expand this write the following expanded form. So using x minus y cube of first minus cube of second minus 3 into first into second, first minus second, right? Here first is x and second is 2 by 3. So cube of first minus cube of second, 3 into first into second and first minus second, right? You will get x cube, this is 827, y cube, negative negative positive, 3 cancel, 2xy and x minus 2 by 3y. Also you can multiply this with this, you will get the required answer. So nothing is tough or technically. Question number 7, I also take third part of this question, that is 9983, and you can use the round number, that is 1000 minus 2 and cube, and using the above identity you can solve it, right? Come to the question number 8. Factorize each of the following. Which question I will take, that is near about to question number 5th. So now take first part. 8a cube plus b cube plus 2 12a square b and 6ab square. Okay, as you see we have two terms of cube form, right, and both are positive one. So which identity is similar to that? That is x plus y cube, x cube, y cube, 3xy, x plus y. How can you say? This is first, this is second, and if you multiply these you will get the form. Okay? Oh sorry, right? Now reverse this polynomial according to this identity. You will get, this is first one, that is 2x cube this is a, this is b, right? Now 3 into first, what is first? That is 2a, into second, that is b, and first plus second. Make verify. 3 to the 6 ab and 6 to the 12, 12a square. This is 12a square, right? 3 to the 6a b square, that is 6ab square. So verified. Now close this, that is 2a first, b second, and the whole cube, right? So this is the reverse process which is used here. Question 8 part we can use, that is 5th one. Okay, 27 p cube 1 by 2 16 9 by 2 p square 1 by 4 p, right? And we see that here two terms are in cubic one, and with negative sign, so identity may be used this, that is x minus y cube means cube of first, cube of second, 3 into first into second, and first minus second. So we can write this as 1 by 6 cube minus 9 by 2 p square 1 by 4 p, right? This can be written as 3p whole cube. This is 1 by 6 whole cube. 3 into first is 3p, into second is 1 by 6. First minus second, first 3p and second 1 by 6. And you will get this first and this is second and the whole cube. Answer. So I think come to the question number 9. Verify this. X cube plus y cube, that is x plus y, x square plus y square minus xy, right? So we have to verify this, means we have to prove left and right are equal, and the way that may be, you have to multiply this as this is 1 x multiply with x square y square minus xy, this is plus y multiply this x square y square minus xy. You will get x cube plus xy square minus x square y y cube xy square. This negative positive negative positive cancel, and you have just remained x cube and y cube. So nothing is difficult. And the question 10, factorize the following: 27y cube and 125 z cube. So which identity is used here? You can see the identity as we have proved above, using that is x cube plus y cube, that equal to x plus y x square minus xy plus y square, right? This is first plus second. Okay, now this can be written as 3y and 5z, right? First plus second. What is first? First is 3y and second is 5z. First plus second. Square of first, that is square of 3y, minus multiplication of first and second, that is 3y into 5z, and square of the second one, that is 5z, square of 5z. And you will see that we will get 9y square, 15yz, 25z square, the required factor. Okay, again question number 11, factorize this: 27x cube y cube z cube 9xyz. Which identity is of the form x cube plus y cube plus z cube minus 3xyz equal to x plus y plus z, x square plus y square plus z square, xy minus yz minus zx, right? So this can be written as the first one is 3x, the second y, and the third one is z. Okay, 3 into first, that is 3x, into second, that is y, and third, that is z. So this can be written as first plus second plus third. First 3x, second y, and third z. Okay, so you can confused by the sign, be okay to that. First plus second plus third, square of first, that is 3x, 9x square, square of second, that is y square, square of third, that is z. X into y, multiplication of first and second, 3xy, second and third, that is yz, and third and first, that is 3x and z. I think very easy. Just we have to keep in mind the proper form of identity which is to be used. Now first we will complete here 13th question. So if x plus y z 0, x plus y plus z 0, then what would happen? As we know, x cube plus y cube plus z cube minus 3xyz equal to x plus y plus z, x square plus y square plus z square minus xy minus zx minus yx minus xz. And as we have given x plus y plus z equal to 0, means this term is 0, this term whole is 0, and you will get x cube y cube plus z cube equal to 3xyz. Okay, easy. Now come to the question number 12. Verify that x cube plus y cube plus z cube minus 3xyz equal to half of x plus y plus z equal to x minus y square, y minus z square, z minus x square. Means we have to prove that both sides are equal. So we have to first open these squares. Square of first, square of second minus first 2 into first second, and applying this you will get this term. Okay, now calculate this as x square here and here, means 2x square y square and y square means 2y square, z square mean 2z square, 2xy, 2yz and 2xz, right? As you see, 2 is common here, and these 2 can be take common here as x plus y plus z, x square, y square, z square, minus xy minus yz minus zx. This 2 is cancelled, and we will get the identity as discussed above in this. Okay, so come to the question number 14. Without actual calculating, find the value of this, that is minus 12 cube 7 cube plus 5 cube. If we take it as a equal to minus 12, b equal to 7, c equal to 5, then we see that a plus b plus c, that equal to minus 12 plus 7 plus 5 equal to 0. So using if a plus b plus c is equal to 0, then a cube plus b cube plus c cube is equal to 3abc. So what will be the value of this number is 3 into first into second into third. So multiply this. This is 36, this is 35. Multiplication of 35 and 36, that will be 1260, right? So you can do this as give possible expression for the length and breadth of, that is question number 15th. We have given the area of a rectangle, that is 25a square, 35a plus 12. If we have a rectangle like this, if this is x, this is y, then area equal to x into y. So we have to find two factors of this, in which one will be length and second will be width. So how will you factorize this? Or you will use identity or any method. I think any method you can use, because here we are not bound to use identities to factorize this. So we will use the splitting method, splitting the middle term one. Okay, what will you do? Here the middle term is 35, and we have to break 35 into two numbers which have the multiplication 25 into 12, right? That is 300. Okay, so we have to find factors which have multiplication 300. That may be 20 and 15. So write 35 as 20 and 15, and take common 5a. We will get here 5a minus 4, and here 3, 5a minus 4. So 5a minus 4 and 5a minus 3, right? which is length and which is breadth. Length is larger than breadth, so larger one is 5a minus 3 and length is 5a minus 3, right? And breadth 5a minus 4. Okay, very easy. Now come to the last question, that is 16, and we have given volume of a cuboid. Volume of cuboid is, what is volume of cuboid? X, Y, Z, right? Length into breadth into height. Okay, so the first part is volume is given as 3x square minus 12x. So we have to make three factors. How? You can take common 3x, you will get x minus 4. So here first is 3, second is x, and third may be x minus 4. So the possible dimension of the cuboid, or you can say possible dimension of cuboid, may be 3x and x minus 4. So, right, I think very easy exercise. And now we will factorize the last question of exercise 2.4, that is fifth one. Exercise 2.4 and question number 5. The first part is factorize this polynomial x cube minus 2x square minus x plus 2, right? Here we see you can use any identity or any method as we have discussed, because we are not bound to use special one. You can use factor theorem also here, and I will try to use factor theorem. So the constant term here is 2, right? Here is 2, and possible factors of 2 are plus minus 1 and plus minus 2, right? By hit and try, you have to find at which value this polynomial is 0, right? So if you put here at x equal to 1, you will get 1 cube minus 2 into 1 square minus 1 plus 2, 1 minus 2 minus 1 plus 2, and you see that is 0. So x minus 1 is factor of px. Another two factors, we can find three factors here because it has 3-degree polynomial. So use division method. X minus 1 and x cube minus 2x square minus x plus 2. You will see here it is x square, x cube minus x that 0 minus x square minus x minus x minus x square plus x cancel, minus 2x plus 2, that is minus 2 minus 2x plus 2, and you see remainder is 0. So x minus 1 and x square minus x minus 2 equal to x cube minus 2x square minus x plus 2. Now make factor of this quadratic polynomial x square minus x minus 2, splitting the middle one, x square minus 2x plus x minus 2, and we see that here x common, x minus 2 and x minus 2. This is x plus 1, this is x minus 2. So you see a process, a question which is not directly been found here using the above process. So alternate, if you can see something here like that, this is 1 and this is 1, and if we take common from here x square, we will get x minus 2 as factor, and this from this also we can get x minus 2 as factor, and so this can be factorized as also. Okay, and this is first square minus second square. Use that identity, first minus second, first plus second, you will get the required factor. Very small question, but using this process or logarithm or division, you have to spend a lot of time to factorize these questions. So again, we can take one more part of this question. I will take third part, that is given as px equal to x cube plus 13x square plus 32x plus 20. So by hit and try, you have to find constant term. Here is 20 and factors of 20 are plus minus 2 plus minus 4 plus minus 5 plus minus 10 plus minus 1 plus minus 20, right? And by hit and try, we will see that P2 minus 2, that is minus 8, and 13 into minus 2 square, 32 into minus 2 plus 20, that is minus 8, that is 52, that is 64, that is 20, and you will see that equal to 0. So you see x plus 2 is factor of the above polynomial, and now you have to divide the above polynomial by x plus 2, and if a factor is of a polynomial, then remainder must be 0, so it can be reduced to a lower degree polynomial, and as you see it will take here as x square, x cube to x square, 11x square plus 32x, 11x and 22x, 10x, and this is 20 and this is minus 10, sorry, plus 10, 10x plus 20, remainder 0, and this quadratic polynomial can be factorized as x square, 10x plus x, 10 and 1, two factors may be seen here. Therefore, the given polynomial can be factorized as x plus 1, x plus 2, x plus 10. If we see alternate here, as we have find that x plus 2 is factor of this polynomial, then x plus 2 can be made common, but we have to make a lot of adjustment for this. So anyhow, in above class, mean 10th class, you will make practice of these type of questions in more ways. And so okay, this chapter is complete. Now I will put my video for assignment of this problem chapter. Okay, thanks.